This question is asking you all about titrations. And the first bit here asks you how or which chemicals we need in order to make the salt ammonium nitrate. Well, if you want to make a nitrate salt, then you have to have nitric acid as part of that neutralization reaction. So the first one of these is nitric acid. And if you remember, acid plus a base, or acid alkali, makes a salt and water. And in order to get the ammonium, we need to have ammonia as the other chemical in that reaction. Which elements combined in ammonium phosphate? Okay, so because this is a 8, that means it contains oxygen. So you can get rid of anything that doesn't contain oxygen. Remember that ammonium is based on ammonia. So actually the ammonium ion is NH4, and here you've got phosphorus with oxygen. So the only sensible option is option D. Titration. So this is showing you some burette readings. So it shows the burette reading at the start and the end of the titration. Calculate the volume added, give your answer to suitable number of decimal places. Okay, so let's just have a look at the start in here. So you can see the start here. Now remember, these scales go from, let me just get a pointer on here for you, goes from 1 down to 2. So this would be 1.5, and that's 1.1, 2, 3, 4. So it's kind of halfway between this. That's actually got a value of 1.45 centimeters cubed. And if we just come over to this side and do exactly the same, there's 27, there's 28, so that's 27.5, there's 0.6, there's 0.7, there's 0.8. Again, it's halfway between them. So here we've got a value of 27.75. And then all we need to do is take those two away to get the difference, and that's the amount of acid that has been added. And we have got ourselves the volume. Be careful, because these should be to two decimal places, two decimal places need to be included, and you can see there we've got that in the response. So the answer down here is 26.30, but make sure, if you're going to get all the marks in this question, make sure you've got your working out and then you've got your answer, because it's a 2-mark answer there to get all the credit. Okay, next question. Student carries out a titration 4 times. The volumes are shown in figure 9. Tick the volumes that should be used to calculate the mean. So what you tend to do in a titration, you are looking for volumes that are within 0.1 centimeter cubed of each other. And the only two that match that criteria is this one here and this one here. The rest of them would be ignored in your calculation. Okay, next little bit. It shows a burette and flask prepared. Okay, and there we go. So we've got all that set up. Student wrote a description how they would use the burette. So it says, took the burette from the cupboard, closed the tap, filled the burette with the correct solution, added it. Okay, so what do they need to do to improve the way they use it? Well, the first thing that we would do is we would rinse the burette with the chemical to be used. So you rinse it through, make sure it's nice and clean for you, and then get rid of the rinse so you've got a nice fresh start. Other thing they should have talked about in here is you need to make sure that the tap beyond the tap is filled. So make sure that fill the jet or fill to the tap to make sure that's done. Other thing on here, let's just check what they did. So they've actually overfilled it above 0, so you wouldn't do that. So do not fill above, and that's 0 centimeters cubed on the point. And it says here until the indicator changes color. Okay, that's okay. Other bit, you can see that the jet thing, that's not filled, and that should be filled to make sure that the volume is accurate in there. So you've got 3 things that need to be done, and there they are. Okay, so titration has been set up. They've added litmus to this and phenolphthalein. The student added the acid, predict the colour change that would be seen. So with litmus, if it was added to the alkali, the litmus would initially be blue, and then because the flask is becoming acidic, it would turn to red. Titration, a student rinsed out the flask with still water and did not dry it. They used the flask for titration, adding solution from the burette until the indicator change colour. State any effect on the titrate volume using a wet flask rather than a dry flask. So because they rinse it with distilled water, this would have no effect because distilled water has a pH of 7 and therefore no impact from that.